So that the height of the cylinder of maximum volume that can be inscribed in a sphere of radius capital R is 2R by root 3. Also find out the maximum volume. So first part we proved, or 3/4 of this question is completed. Now a half part is remaining, 1/4 is remaining, that is find out the maximum volume. So we took the diagram like this, a circle that is inscribed in a sphere. Capital R is the radius of the sphere, it was given. So we took small r and small h as the radius and height of the cylinder. Volume of the cylinder we took. Then we defined it as, named it as f of h, and f dash h we found equated it to 0, and h is 2r by root 3. And then we have completed second derivative. Second derivative is negative. Therefore, the volume of the cylinder is maximum. Yes, did you get the maximum volume? For that, you will substitute it in the maximum volume expression. The value of h, you will substitute h is 2r by root 3. You can find out the maximum volume. So please see that part. So this is the homework part. So how many of you have done that one, the homework, to find out the maximum volume? So I will write that calculations here. Maximum volume is equal to, you will copy that volume expression. Volume we have simplified in terms of h. What was that? Pi r square h minus h cube 3h square pi h cube pi by 4. Okay, so from there you will simplify to get the maximum volume. So I will write like this: pi r square h. This is the volume we simplified. Pi r square h minus h cube pi by 4. Pi r square h minus h cube pi by 4. Okay, so that Eric D'Souza is Justin D'Souza only. Is it Justin?
Yes, sir, yeah.
Okay, fine. So pi r square h minus h cube pi by 4. So in this expression, you have to substitute h. H is 2r by root 3, that you will substitute. Then you can easily get the answer. Yes, can you try that simplification? It will be pi r square into 2r by root 3. H is 2r by root 3. Or after taking h common factor outside also we can do. So I will do accordingly. Otherwise it will be a little bit complicated if I don't take h outside. So when I take h outside, it will be 4 pi r square h. I took the common factor in this step. Okay, so then pi h we can take outside. Pi h into, then we get 4r square minus h square by 4. 4r square minus h square by 4. So this is the continuation of last class sum. Then we substitute pi into h is 2r by root 3. Then inside the bracket 4r square minus h square means 2r by root 3. The whole square, we will close this bracket here, all divided by 4. That is pi into 2r by root 3. Or we can cut this 2 and 4, it will become 2. Then again, simplification is possible. Pi into r by 2 root 3, r by 2 root 3, r by 2 root 3, this 2 will go up. Then 4r square minus 4r square by 3, 4r square by 3. That is pi r by 2 root 3 into 3 4s are 12 r square minus 4r square by 3. Now 12 minus 4 is 8. This will be 8 r square by 3. We can again cut this 2 and 8. It is 4. So these two will go 2 and 8. So this will be 4. So the final answer is 4 pi r cube upon 3 root 3. This is the volume, maximum volume. 4 pi r cube by 3 root 3 is the maximum volume. So this was the homework part. Some students have already completed this one. They can verify their answer. Others have to do it right now. It is a continuation of that last class sum. Okay, so now the next question. This is a worked out example from the miscellaneous exercise of NCERT. Please write. An Apache helicopter of enemy is flying along the curve given by the curve given by y is equal to x square plus 7. Y is equal to x square plus 7. Full stop. A soldier placed at 3,7. A soldier placed at 3,7, coordinate 3,7. A soldier placed at 3,7 wants to shoot down the helicopter when it is nearest to him. When it is nearest to him. Find the nearest distance. Find the nearest distance. Please write this question. Like this. It is y is equal to x square plus 7. Equation of the curve is y is equal to x square plus 7. Then a soldier placed at 3,7. Soldier placed at 3,7. So I take the point, let P 3,7 be the point where soldier stands. And he wants to shoot down the helicopter. Helicopter is flying along this curved path. When it is nearest to him, suppose this is the nearest distance. Okay, the shortest distance. So I will take this point as Q. So let Q, H comma K be the point on curve such that PQ is nearest. Nearest means maximum or minimum. That is a function to be taken. Nearest distance means it is the minimum distance. So we have to find out the distance using distance formula, and then you will apply the condition for minimum. That is the question. So please draw a rough diagram. A curve y is equal to x square plus 7. Then the coordinate 3, 7. It is a point where soldier stands. So we took a point QHK on the curve such that PQ is minimum. Then you have to find out the distance using distance formula, apply the condition for minimum. So let's start. Let capital P 3, 7 be the given point. Let P 3, 7 be the given point. Be the given point. Then we write, let QHK be a point on the curve so that PQ is minimum. PQ is minimum. Okay, so now there are two variables in that Q, the coordinate of Q, H and K. We can easily write it in terms of one variable. For that, we use that curve equation. Since QHK is a point on the curve, so this is a point on the curve, y is equal to x square plus 7. So this is a point on the curve, y is equal to x square plus 7. We will substitute here, k is equal to h square plus 7. K is equal to h square plus 7. We will use this for further substitution, equation number 1. So this is the way of writing one variable k in terms of the other variable h. Because when we do the maximum minimum sums, we are not allowed to take two variables or more variables. So this will help us in the sum to write it in terms of one variable. Since that point is a point on the curve, we have to replace x and y with this point h and k. Yes, now we are going to take the distance PQ using distance formula. Distance PQ using distance formula. According to our question, the distance should be minimum. Distance PQ is root of h minus 3 the whole square plus k minus 7 the whole square. Root of h minus 3 the whole square plus k minus 7 the whole square. This is the formula for distance PQ. Okay, so now I will substitute in place of k. K is h square plus 7. So this is in terms of two variable. We are going to write it in terms of one variable now. Root of h minus 3 the whole square plus k is h square plus 7, then minus 7 the whole square. So from equation number 1, I substituted here k is equal to h square plus 7. Now this plus 7 and minus 7 will go. So we get root of h square minus 6h plus 9 plus h raised to 4. That will be root of h raised to 4 plus h square minus 6h plus 9. Root of h raised to 4 plus h square minus 6h plus 9. This is the distance PQ, okay? Please write the distance PQ. Then after writing the distance PQ, we will do the square of this step, because this is a root function. It is very difficult to do the derivatives and all after this step. So to avoid that difficulty in doing the derivative, we have to do the squaring on both sides. We have done in few questions the same steps, squaring on both sides. And that squared function to be taken as f of h. So the next step is squaring on both sides. Squaring on both sides, we get PQ square is equal to h raised to 4 plus h square minus 6h plus 9. This is our f of h. Let f of h is equal to this h raised to 4 plus h square minus 6h plus 9. Okay, so this is our f of h. Let f of h is equal to h raised to 4 plus h square minus 6h plus 9. Okay, children, now after writing f of h, we will find out f dash h. F dash h is equal to 4h cube plus 2h minus 6. 4h cube plus 2h minus 6 is f dash h. Now you will equate it to 0 and find out the value or values of the variable h. Now let f dash h is equal to 0 implies 4h cube plus 2h minus 6 is equal to 0. Are you following it? Did you reach till the step, children?
Yes, sir.
Okay, now we have to factorize this by trial and error method. In small classes, class 9, we studied a cubic polynomial factorization by substituting 1, minus 1, 2, minus 2, etc. until we get polynomial value is equal to 0. Then if p of 1 is 0, x minus 1 will be factor. Here h minus 1. I can divide this throughout by 2. Then we get 2h cube plus 2h minus 3 is equal to 0. 2h cube plus h minus 3 is equal to 0 when we divide by 2. All right, so now I will do in the rough for the calculation, some calculations. The calculations will be like this. If this is polynomial of h, this is the trial and error method of cubic polynomial factorization. If I substitute h as 1, will it be 0?
Yes, sir.
It is 0. It is 0. So 3 minus 3, that is equal to 0, right? So we got p of 1 is equal to 0. Therefore, h minus 1 is a factor of this p of h. You may remember this method in small classes, you have studied this. And then what to do after finding one factor? How will you find out the remaining factors? We have to divide this polynomial by h minus 1. All of you please note down this calculation, the trial and error. We got p of 1 itself 0. In case if p of 1 is not 0, we have to keep on substituting p of minus 1, p of 2 until we get one of them 0. Yes, now I will divide this 2h cube plus h minus 3. There is no h square, so I will write it 0h square plus h minus 3 divided by h minus 1. All of you know the long division. First step is 2h cube by h. 2h cube by h is 2h square. We will write 2h square in the quotient. Then multiply 2h square into h is 2h cube plus minus 2h square minus 2h square. Then you will subtract. This goes minus. So this will be plus. These two will go. 0 plus 2, 2h square plus h minus 3. 2h square by h is 2h. In the quotient 2h, then again we multiply 2h square minus 2h, subtraction minus, here plus, these two will go. 3h minus 3, again 3h by h is 3, 3h minus 3. So we have to get the remainder 0, otherwise it is wrong. So here it is correct, the remainder is 0. Okay, so this is the quotient. Please do the long division. And then we have to check the possibility of factorizing the quotient. If it is possible to factorize, we will get 2 more zeros or 2 more roots for this polynomial. Total 3 roots we can find out. Okay, so let me check the possibility of factorization. So here we got h minus 1 into, h minus 1 is the first factor into 2h square plus 2h plus 3 is equal to 0. Okay, so from there, h minus 1 is equal to 0 means h is equal to 1 is one of the roots of this polynomial. And second is 2h square plus 2h plus 3 is equal to 0. It is very difficult to find out the factors, factorization. Sum is 2 and product is 6. Is there any factor? Sum is 2 and product is 6. Difficult. So I will check the other method, discriminant method. Discriminant is b square minus 4ac. What is that? B square minus 4ac in this polynomial. 2 square minus 4 into 2 into 3. That is 4 minus 24 is minus 20. That is less than 0. If d is less than 0, what will be your conclusion? If d is less than 0?
No real roots exist.
No real.
For this polynomial, no real roots exist. So this implies there is no real root for the second factor polynomial. No real roots exist for the second factor polynomial. So there is only one real root, that is h is equal to 1. Therefore, h is equal to 1 is the only one real root. Okay, so the other real roots doesn't exist. So we cannot find out more real roots for this cubic polynomial. There is only one real root, that is h is equal to 1. Is it clear, children, this step? I have factorized this one. Before that, by trial and error method, we found the polynomial root, one of the root as p of 1. Then h minus 1 is a factor. So we have divided, long division is done by h minus 1. So then we got the remainder 0. So h minus 1 into the remaining factor is equal to 0. So h is 1 is the real root, but for the other polynomial, we don't get real root. Okay, so we found in anyway one of the values of h. Next step is find out the second derivative and prove that second derivative is positive when we substitute this h is equal to 1. Then you can conclude that the distance PQ will be minimum. Distance PQ will be minimum, and then you will find out the minimum distance. Okay. So this is the next step. I will copy f dash h. What was f dash h from the last step? 4h cube plus 2h minus 6. This was our f dash h. Next is f double dash h, the second derivative. F double dash h is 4 into 3h square, that is 12h square plus 2 is equal to 12h square plus 2. This is a f double dash h. Then f double dash h at h is equal to 1 is 12 into 1 square plus 2 is 40. It is clearly greater than 0. Okay, the second derivative is clearly greater than 0. Second derivative is greater than 0 means what do you conclude there? The distance PQ is minimum at h is equal to 1. Therefore, the distance PQ is minimum at h is equal to 1. The distance PQ is minimum at h is equal to 1. Then the conclusion, find out the minimum distance. So distance already we have written in terms of h. We will copy that step and substitute h is equal to 1. So the minimum distance PQ is equal to, according to this question, we will write the minimum distance. This was the minimum distance expression, root of, we have simplified and got like this, h raised to 4 plus h square minus 6h plus 9. In the above step, it is there. So from this step only we have done the squaring and all. So here we will substitute h is equal to 1. Then what do you get? Please calculate. 1 raised to 4 plus 1 square minus 6 into 1 plus 9. What is this answer? 1 raised to 4 is 1. So 1 plus 1 minus 6 plus 9. Positive numbers when we add 1 plus 1, 2, 2 plus 9, 11. 11 minus 6 is equal to root 5, right? Root 5 units. So therefore the minimum distance is root 5 units. So this is a solved example from NCERT textbook. So please practice this question very well. So this question, it was based on distance between 2 points. Okay. So in reference books, we have a distance of a point from a curve. Last year's concept is there. Modulus of ax1 plus by1 plus c by root of a square plus b square from a line, distance of a point from a line. So that one I will either explain later or I will send you a solved example of that type. Okay, solved answer of that type for your practice later. Okay. Yes, now we have 2 more sums from NCERT miscellaneous exercise. Please write the next question. So hope you all completed this one. Okay, so write the next one from miscellaneous exercise. Find the maximum area of an isosceles triangle of an isosceles triangle inscribed in the ellipse. Inscribed in the ellipse. X square by a square plus y square by b square is equal to 1, with its vertex at one end of major axis. With its vertex at one end of major axis. Please write this question. Okay, so all the informations are clearly in the question, but we have to apply the formula for area of triangle. It's a different question. Find the maximum area of an isosceles triangle. So question is to maximize the area, maximum area of isosceles triangle inscribed in the ellipse. So we will draw an ellipse, isosceles triangle inscribed in the ellipse. So let's draw an ellipse. Please draw an ellipse. Like this. Then an isosceles triangle inscribed in this ellipse. We will draw the x-axis and y-axis also. This is the x-axis. Then y-axis. Okay, so then we draw an isosceles triangle inscribed in the ellipse, and one condition is given with its vertex. This is the condition given with its vertex at one end of major axis. So we know capital A, I will highlight one of the major axis here. So this one, capital A. Coordinate of capital A, everybody knows, minus a comma 0. Last year we studied detail about ellipse. This is minus a 0. And this is the other end of major axis. So I will keep the isosceles triangle vertex on this end at A. Then we will complete the isosceles triangle from A to the ellipse, and from A to the other part. Then we will join these two. So this is the isosceles triangle. So let's name the isosceles triangle ABC. So ABC is the isosceles triangle. So look at the isosceles triangle as per the question. It is clearly inscribed in the ellipse with its vertex at one end of major axis. So here capital A is the vertex at one end of major axis. Okay, major axis, all of you know. So capital A is one end of major axis. Next is a very important point I'm going to explain. So here I will take this angle. the semi-vertical angle as theta. If this angle is theta, then capital B will be, we don't have to write the detailed calculation. It is A cos theta, comma B sin theta. Every point on ellipse will be of that form. A cos theta, comma B sin theta. But according to quadrant, we put the sign. So capital B is a point in first quadrant. First quadrant, both X and Y are positive. So on an ellipse, every point is of this form. A cos theta, comma B sin theta. But when we write the point C, it is in fourth quadrant. What can you say about fourth quadrant? What will be positive? Which coordinate will be positive in fourth quadrant? X will be positive and Y will be negative. So the same coordinate we write here also, but A cos theta, comma minus B sin theta. So if it is a rectangle, in NCERT exemplar question, the same question is there. Instead of isosceles triangle, rectangle inscribed in an ellipse. That time we get the points in third and second quadrant. So there also we take the same coordinate, but the sign we will put according to the quadrant. So this is a form of any coordinate using theta in an ellipse. A cos theta, comma B sin theta. You can note down that in the reference space. Any point on ellipse is of the form. It is a parametric form. A cos theta, comma B sin theta. Any point on ellipse is of the form A cos theta, comma B sin theta. You don't have to write the detailed proof of that one. So that we can derive by taking the points, distances A and B, and the semi-vertical angle and the right triangle. So any point on ellipse is of the form A cos theta, comma B sin theta. Okay, so we will write the introduction, or those who have not written, don't worry, I will write again in the introductory part of that same point. So we have to find ultimately the area of the isosceles triangle for this question. That is the function to be maximized. So I was drawing this type of ellipse because it is the first type of ellipse. X square by A square plus Y square by B square is equal to 1. So we'll start with that introduction. Consider the ellipse. X square by A square plus Y square by B square is equal to 1. Then any point on the ellipse is of the form, any point on the ellipse is of the form A cos theta, comma B sin theta. But it will change according to the quadrant sign. Then let triangle ABC be an isosceles triangle inscribed in the given ellipse. Be an isosceles triangle inscribed in the given ellipse. Inscribed in the given ellipse. Okay. Now we can easily write the coordinates of triangle ABC. It is already written in the figure. Coordinates of triangle ABC. Coordinates of triangle ABC are capital A x1, y1 is minus a comma 0. Capital B, x2, y2 is a cos theta, comma b sin theta. Then capital C, x3, y3 is a cos theta, comma minus b sin theta. Okay, so these are the coordinates of triangle ABC. Coordinates of triangle ABC, x1, y1, x2, y2, and x3, y3, you can note down. Okay, so then in the chapter determinants, we studied area of triangle formula using determinant. That formula was like this. Area of triangle ABC is, do you remember the determinant formula? Half into determinant, x1, y1, 1, then x2, y2, 1, x3, y3, 1. This is the determinant formula, okay? So either we can substitute in this determinant formula and expand, or the expanded form also can be used, okay? So what will be easy for you? Accordingly, we can find out the area from this determinant formula. Either we can substitute in this determinant formula and expand, or using the area formula also, we can simplify this and expand this, okay? So I will substitute in this determinant formula and simplify this. So this is the area of triangle ABC formula, the determinant formula. So I will substitute in this one. According to the question, we have to find out the area of triangle ABC. So area of triangle ABC is half into determinant x1, y1, 1, that is minus a 0, 1, x2, y2, 1. It is a cos theta b sin theta 1, then x3, y3, 1. That will be a cos theta minus b sin theta 1. A cos theta minus b sin theta 1. So if three coordinates are given, we can easily use this determinant formula. But when we calculate, in case if it is negative, we will take the modulus value of this one. So it will be under the whole modulus. We can take the modulus value of this later. Or here itself, I will put modulus value of this determinant. So that will be half into, so let's evaluate this. All of you know how to evaluate a determinant. Minus a into, remove its row and column. Then we get a b sin theta minus b sin theta, that is plus b sin theta. Next term is 0. Then plus 1 into, okay, remove the first row and the last column. Then it will be minus ab sin theta cos theta, minus ab sin theta cos theta, minus ab sin theta cos theta. So this is the simplification. It will be under the whole modulus because this quantity cannot be negative. So is it clear, children? The determinant we have expanded easily. All of you know determinant, you have studied detailed the determinant chapter. So this is half into minus a into 2b sin theta, or it will be minus 2ab sin theta. First term becomes minus 2ab sin theta. Next is minus 2ab sin theta cos theta. minus 2ab sine theta cos theta. Minus 2ab sine theta cos theta. This will be under Hall modulus. We can take that negative 2 outside, or that sine theta cos theta, we can write sine 2 theta also later, but I will take negative 2 outside. That will be easy way of simplification for this one. So half into negative 2 into, even AB also a common factor. Sine theta is a common factor. So minus 2AB sine theta. Then what do you get inside the bracket? Minus 2AB sine theta after taking 1 plus cos theta. 1 plus cos theta. This will be under Hall modulus. This 2 and 2 will go. Modulus of negative will be positive. So this will become AB sine theta into 1 plus cos theta. Here A and B are constants. There is only one variable, that is theta. Remaining steps are similar to our normal calculation. So this one all of you understood? For this question, only problem is, remember that coordinate form in ellipse, A cos theta, comma, B sine theta, and put the sign according to the quadrant. Here one point it was in first quadrant and the other one fourth quadrant. One of the point is minus a comma 0, the end point of major axis. Then if we will write this determinant formula for area of triangle that I wrote and substituted easily, and we got this area function. Now the remaining steps are our normal steps. This is f of theta, find out f dash theta, equate it to 0, then second derivative. So we continue, let f of theta is equal to AB sine theta into 1 plus cos theta. Okay, then f dash theta. F dash theta is equal to, here by product rule, AB is a constant. AB sine theta is the first term into derivative of 1 plus cos theta is minus sine theta plus 1 plus cos theta into 1 plus cos theta into AB cos theta, AB cos theta. Or after taking AB outside also, we could have done the same thing. Here I applied the product rule. First function AB sine theta into derivative of second, plus second function 1 plus cos theta into derivative of first. Okay, so we will open this bracket. Some more simplification is possible here. AB can be taken outside. Then it will be minus sine square theta plus cos theta plus cos square theta. AB is taken outside, then the remaining part is simplified. That is AB into cos square theta minus sine square theta can be taken together because it is a standard form. What is cos square theta minus sine square theta? Cos square theta, cos 2 theta, correct, cos 2 theta. So AB into cos 2 theta plus cos theta. Please write till this step. After this, we will equate it to 0. So there is only one variable, that is theta. We are going to find out theta. Okay, so after this step, equating it to 0. So is it clear, children? Derivative by product rule. Okay, so now we equate it to 0. F dash theta is equal to 0 implies AB into cos 2 theta plus cos theta is equal to 0. Here AB cannot be 0. The remaining part can be 0. That is cos theta, cos 2 theta, cos 2 theta plus cos theta is equal to 0. So here I will apply some formula, cos A plus cos B. Do you remember cos A plus cos B? Both cos, right? Cos A plus cos B. If you don't know, please write that formula in the reference page. Cos A plus cos B is 2 cos A plus B by 2, cos A minus B by 2. I repeat, cos A plus cos B is 2 cos A plus B by 2, cos A minus B by 2. Okay, so when we apply that formula to this 2 cos 2 theta plus theta by 2 into cos 2 theta minus theta by 2. This is equal to 0. So it comes like this, 2 cos 3 theta by 2 into cos theta by 2 is equal to 0. So the product is equal to 0 means either the first factor is equal to 0 or second factor is equal to 0. So which means either cos 3 theta by 2 is equal to 0. Here theta is an acute angle only. So 3 theta by 2 is, we don't have to take any general solution, is equal to pi by 2 because cos 90 is 0. So is pi by 2. 2 and 2 will go. Theta is pi by 3. This is possible being an acute angle. So theta is pi by 3 by the first factor equating to 0. Now, if you equate the second factor to 0, what will be the value of theta? Here also, theta by 2 is pi by 2. What is theta from here? Theta is pi. Is it possible?
No.
Not possible because theta is an acute angle. As per our marking in the diagram, it is a semi-vertical angle, so which is not possible since theta being an acute angle. So this is not possible. So this value is rejected in the step itself. We are not going to proceed with theta as pi. So there is only one value for theta, that is pi by 3. Okay, so all of you please complete till this step. So next step, you will find out the second derivative and prove that the second derivative is negative. For maximum area, second derivative must be negative. So I will copy the first derivative. Hope you all completed till this step. Okay, so now I will copy the first derivative. What was the first derivative? F dash theta AB into the simplified form cos 2 theta plus cos theta. AB into cos 2 theta plus cos theta is F dash theta. Now F double dash theta F double dash theta is AB into derivative of cos 2 theta is minus sine 2 theta into 2, then minus sine theta. We can take minus outside, minus AB into 2 sine 2 theta plus sine theta plus sine theta. So we found F dash theta minus AB, F double dash theta minus AB into 2 sine 2 theta plus sine theta. Is it clear? Okay, now we will substitute theta as pi by 3. F double dash theta at theta is equal to pi by 3. We get minus AB into 2 sine 2 into pi by 3 plus sine pi by 3 plus sine pi by 3. Okay, so that is minus AB into sine 2 into pi by 3. Sine 2 pi by 3. What is sine 2 pi by 3? That we have to calculate in the rougher space. Sine 2 pi by 3 means sine 120. Can you say, children, what is sine 120? What is sine 120? Sine 2 pi by 3 means sine 120. What is that? Sine 180 minus 60. This is in the second quadrant. Second quadrant sine is positive. So it is sine 60 root 3 by 2. Sine 2 pi by 3 is root 3 by 2. Sine pi by 3 means that is also root 3 by 2. Sine 60. So please note down sine 2 pi by 3. That we substitute to the step 2 into root 3 by 2 plus root 3 by 2. So this is clearly negative. Minus AB into 2 root 3 plus root 3, that is 3 root 3 by 2 is clearly less than 0. So this is less than 0. Therefore, we can conclude area of the ellipse, area of the isosceles triangle is maximum at theta is equal to pi by 3. Therefore, area of the isosceles triangle is maximum at theta is equal to pi by 3. Yes, did you write the conclusion? Area of the isosceles triangle is, therefore, area of the triangle means isosceles triangle is maximum at theta is equal to pi by 3. Now the next step is to find out the maximum area, conclusion. Okay, maximum area. For that, you will copy the area expression. Now the maximum area is equal to, so this was the area that we have already written, AB sine theta into 1 plus cos theta from the above steps. There we substitute theta. AB into sine pi by 3 into 1 plus cos pi by 3. That is AB into sine pi by 3 is root 3 by 2. Into 1 plus cos pi by 3 is cos 60, 1 by 2. Please simplify this. This will be the maximum area. You will write the answer in square units. So AB into root 3 by 2. 1 plus 1 by 2 is 3 by 2. So the final answer is 3 root 3 by 4 AB square units. Please write. 3 root 3 by 4 AB square units. 3 root 3 by 4 AB square units is the final answer. Okay, so this completes this question. So this was a bit lengthy question, but all of you have to note down the calculations and practice it very well. The similar type of one more question is there in the miscellaneous exercise. That will be the last sum. So by that, we can complete this chapter and almost all the possible questions also. But for this similar type of a question is in NCERT exemplar book, instead of isosceles triangle, a rectangle is given. And that also to find out the area of rectangle using length into breadth. The length and breadth we have to find out using distance formula. So that the coordinates you will take the same way, a cos theta, comma, b sin theta according to quadrant signs. Yes, hope you all completed this one. Now the last question, please write. A point on the hypotenuse of a triangle a point on the hypotenuse of a triangle is at a distance A and B from the sides of the triangle. A and B from the sides of the triangle. Show that the minimum length of hypotenuse is the minimum length of hypotenuse is a raised to 2 by 3 plus b raised to 2 by 3, the whole raised to 3 by 2. Minimum length of hypotenuse is a raised to 2 by 3 plus b raised to 2 by 3, the whole raised to 3 by 2. A raised to 2 by 3 plus b raised to 2 by 3, the whole raised to 3 by 2. Okay, so let's draw a right triangle. This question is based on a right triangle. That is what hypotenuse is mentioned. Hypotenuse of a triangle means it will be a right triangle. At a distance, a point on the hypotenuse is at distance A and B from the sides of the triangle. That means from base and altitude, distances A and B unit. Okay, so let's draw a right triangle. Please draw a right triangle. First, I draw the base and altitude. Like this. Then we name the right triangle ABC. Here A, B, C, the right triangle ABC. This angle is 90 degrees. So let's take a point P on the hypotenuse. P on the hypotenuse. Then the distances we have to take A unit and B unit from the sides. That means this distance is A unit. From P, we should take the perpendicular distances. Like this A unit and B unit, the two distances. This is A unit and this distance is B unit. So our question is to find out the minimum length of hypotenuse. That means length of hypotenuse is the function to be minimized. So I will take, let y be the length of hypotenuse. So this total length, we take y. And one more important thing, we will take an angle theta as there in the last sum to apply trigonometry. So let this angle be theta. If this angle is theta, by corresponding angle, this angle A also will be theta. So angle A and angle CP, let's write a name here, E. And here it is D, okay, the 2 points. So this PD is perpendicular, P is also perpendicular. So why we are going to write as a sum of AP and PC. AP and PC we will find out in terms of theta, A and B. That is the calculation of this question. And then finally you will find out, prove that the hypotenuse, length of hypotenuse is minimum, and the minimum length of hypotenuse also you can easily find out. Yes, please complete the diagram. And let's start the introduction. This question is also an important question from the miscellaneous exercise of NCERT. Now, according to question, is it clear, children, the diagram? Right triangle, point on hypotenuse P is taken. That is at a distance. Distance means it is always perpendicular distance. A unit from one side AB and B unit from the other side BC. We have to prove that the length of hypotenuse is minimum. I took the length as y. So write the introduction. Let P be a point on the hypotenuse. Let P be a point on the hypotenuse of right triangle ABC such that PD is equal to small letter A and PE is equal to small letter B. PD is equal to small letter A and PE is equal to small letter B. PD is small letter A and PE is small letter B. Then let y be the length of hypotenuse. Small letter y be the length of hypotenuse. Now, first we take the triangle ADP and we will find out AP and then PC from triangle PEC, then y will be AP plus PC. That is the procedure of this question. Okay, in triangle ADP, sine theta, because A is the opposite side and AP is the hypotenuse. So I take sine theta, opposite side PD by hypotenuse AP. That is A by AP, or AP is equal to A by sine theta. That is equal to A cosec theta. AP is A cosec theta. We will use this for further substitution. AP is A cosec theta. Please write. First we took the triangle ADP and we took sine theta. Next is triangle PEC. In triangle PEC, there we take cos theta. Cos theta is equal to PE by PC. That is B by PC. The same way PC we can find out. PC is equal to B by cos theta. That is equal to B sec theta. PC is B sec theta. Please write. So PC is a B sec theta. Now we can write the length of hypotenuse y is AP plus PC. Then we substitute these values. So we get the length of hypotenuse in terms of one variable theta. So that is the next step. Length of hypotenuse y is equal to, right, length of hypotenuse y is equal to AP plus PC. That is equal to A cosec theta plus B sec theta. This is the required function. A cosec theta plus B sec theta. This is a function of theta. So we can call this as f of theta. So let f of theta is equal to A cosec theta plus B sec theta. F of theta is A cosec theta plus B sec theta. Did you reach till here, children? The function we have taken, y is the sum of AP and PC. Okay, then as usual, we find out f dash theta, the first derivative. A into derivative of cosec theta. What is derivative of cosec theta? Minus cosec theta, correct. Plus B into derivative of sec theta. What is derivative of sec theta?
Sec theta tan theta.
Correct. Sec theta tan theta. Sec theta tan theta. Okay, so then we equate it to 0. F dash theta is equal to 0. So f dash theta is equal to 0 implies minus A cosec theta cot theta plus B sec theta tan theta is equal to 0. So which means A cosec theta cot theta is equal to, or B sec theta tan theta is equal to, I will write like that. B sec theta tan theta is equal to A cosec theta cot theta. That minus term that has been taken to the right side in the step. B sec theta tan theta is A cosec theta cot theta. That means B into sec theta is 1 by cos theta. Tan theta is sin theta by cos theta is equal to A into 1 by sin theta into cos theta by sin theta, cos theta by sin theta. Now let's take all the sine terms to left side. Here sine square, here cos terms to the right side. That means B into, totally we get sine cube theta is equal to A into cos cube theta. So we are going to find out theta from here. That is sine cube theta by cos cube theta is equal to A by B. Sine cube theta by cos cube theta is A by B. Is it clear, children, these steps? Simple trigonometry only done here. What is sine cube by cos cube?
Tan cube theta.
Tan cube theta. So tan cube theta is A by B. So we have to reach till theta. So what is tan theta from here? cube root of a by b. Cube root of a by b can be written as a by b the whole raised to 1 by 3. A by b the whole raised to 1 by 3. So theta is equal to tan inverse a by b the whole raised to 1 by 3. So this is theta. The value of theta we found, tan inverse a by b the whole raised to 1 by 3. So please write till here. After this, we will find out the second derivative and prove that the second derivative is positive for this question. Then only we can write it is minimum. Okay, first derivative is done, equated to 0. Okay, now I will proceed with the first derivative. F dash theta is minus a cosec theta cot theta plus b sec theta tan theta. This is f dash theta. Now f double dash theta minus a into, here we have to apply product rule because cosec and cot, two functions are there, so product rule. It is cosec theta into derivative of cot theta is minus cosec square theta plus cot theta into minus cosec theta cot theta. Okay. I have applied the product rule here. Cosec theta into minus cosec square theta plus cot theta into minus cosec theta cot theta. For the second term also the same, b into sec and tan, two functions. So sec theta into derivative of tan theta is sec square theta plus tan theta into derivative of sec theta is sec theta tan theta, right? Sec theta tan theta. So from the first bracket, minus we can take outside, right? There are two negative signs in first bracket. So that when we take outside, this will become positive. A into cosec cube theta plus cosec theta cot square theta. Cosec theta cot square theta. Second term is already positive, that is b into sec cube theta plus sec theta tan square theta. So theta is an acute angle. You can see this theta and this theta in the figure also, it is acute angle. So when we, and this is purely positive. So when we substitute an acute angle, this will be greater than 0. So since there is no negative term and theta is an acute angle, this f double dash theta is greater than 0. So since there is no negative term and theta is an acute angle, we can write f dash theta is greater than 0. Therefore, f double dash theta is greater than 0. Therefore, we can conclude that the length of hypotenuse is minimum. Therefore, the length of hypotenuse is minimum at theta is equal to tan inverse a by b the whole raised to 1 by 3. Length of hypotenuse is minimum at theta is tan inverse a by b the whole raised to 1 by 3. And then the concluding part. Concluding part is prove that minimum length of hypotenuse is a raised to 2 by 3 plus b raised to 2 by 3, the whole raised to 3 by 2. Yes. Did you reach till here? Second derivative is found. And we proved the second derivative is positive because theta is an acute angle. And there is no negative term in the second derivative. It is clearly positive. So length of hypotenuse is minimum at theta is equal to tan inverse a by b, the whole raised to 1 by 3. Now the last part I am not giving homework. If you can wait 5 more minutes, I will explain that last concluding part of this question so that we can fully complete this question here itself. So I will explain that also, okay? Last part is find out the minimum length, and that minimum length answer is given in the question. So for that, we will copy the length of hypotenuse y is equal to from the steps a into root of 1 plus cot square theta plus b into root of 1 plus tan square theta. So then we substitute for cot theta and tan theta. Tan theta is a by b, the whole raised to 1 by 3. From the above step. What is cot theta? It's reciprocal. So what will be cot theta, children? B by a, the whole raised to 1 by 3. That we substitute to this. Then you will get that answer. A raised to 2 by 3 plus b raised to 2 by 3, the whole raised to 3 by 2. So this will be a into root of 1 plus a by b, the whole raised to 1 by 3, or this is b by a. Cot theta is b by a. B by a, the whole raised to 1 by 3, the whole square. Like this. Plus b into root of a by b, the whole raised to 1 by 3, the whole square. That will be a into root of 1 plus b by the whole raised to 2 by 3 plus b into root of 1 plus a by b, the whole raised to 2 by 3. Then we can take the LCM. Taking LCM, that will be a into root of a raised to 2 by 3 plus b raised to 2 by 3 by a raised to 2 by 3 plus b into root of b raised to 2 by 3 plus a raised to 2 by 3 by b raised to 2 by 3. Okay. So we can take this as a common factor outside. Under the root, a raised to 2 by 3 plus b raised to 2 by 3 is a common factor. Then within 2-3 steps, you will get the answer. So this will be root of a raised to 2 by 3 plus b raised to 2 by 3 into a by a raised to 2 by 3 plus b by b raised to 2 by 3. That is root of a raised to 2 by 3 plus b raised to 2 by 3 into a by a raised to 2 by 3 is, we can subtract the root a by a root of, this was root of and this is also under the root. Root means raised to 1 by 2. That means a by a raised to 2 by 3 raised to 1 by 2 plus b by b raised to 2 by 3 raised to 1 by 2. Then that 2 and 2 will go. Raised to 1 by 3 we get. So is it clear? I took the common factor. Then a by root of a raised to 2 by 3 means a raised to 2 by 3 raised to 1 by 2. So simple law of indices only I apply here. So this is a raised to 2 by 3, law of exponents. So this is a raised to 1 by 3 plus b by b raised to 1 by 3. No, a by a raised to 1 by 3 means a raised to 1 minus 1 by 3. What is 1 minus 1 by 3? 2 by 3. Similarly, the next also we get b raised to 2 by 3. So this will be a raised to 2 by 3 plus b raised to 2 by 3 under the root. And this is a raised to 2 by 3 plus b raised to 2 by 3. Root means raised to half. So raised to half into raised to 1. That will be a raised to 2 by 3 plus b raised to 2 by 3 raised to half plus 1. Whole raised to half and whole raised to 1. So we get a raised to 2 by 3 plus b raised to 2 by 3, the whole raised to 3 by 2. This is the minimum length of hypotenuse. Okay. So these two sums in the miscellaneous were a bit lengthy, but you have to practice this also very well so that you can say 100% you have completed if you practice these two questions also. Okay.